Okay, welcome guys. So in this video, we're going to talk about molar mass. Okay, so let me do a small recap on what we did in the previous video. So in the previous video, we started with mole concept and we explained what a mole is and we also explained Avogadro's constant. So today, we're going to continue the mole concept. For you to know mole concept well, or for you to solve a mole of a substance, there is one thing that you have to know, which is molar mass. So today we're going to talk about molar mass. Okay, so on the script written on the sheet, we are saying molar mass is the mass of 1 mole of substance. So it's just repeated. So molar mass is the mass of 1 mole of substance. Okay, so molar mass is the mass of 1 mole of a substance. So that's molar mass. So if you take molar mass of any substance is equal to the relative molecular mass. So if you say relative molecular mass, if you take a molecule like sodium chloride, a molecule like sodium chloride, a molecule like sodium chloride. So if you take sodium chloride as example, the whole of this is a molecule. So if you want to find the relative molecular mass, you add the individual atomic masses. So the atomic mass of sodium plus the atomic mass of chlorine. So that's relative molecular mass. And relative molecular mass is equivalent to molar mass. Just that molar mass has a unit, but relative molecular mass don't have a unit. Don't have a unit. Okay, so we're going to talk about relative molecular mass and relative atomic mass or atomic masses. So they are the individual masses. So for sodium, if you take the periodic table, you see that the mass of sodium is 23. So Na equal to 23. Also, for chlorine, Cl equal to 35.5. These are their relative atomic masses. If you add their relative atomic masses, you get the relative molecular mass of this molecule. So that's molar mass. So I'm going to take example so you guys will understand the molar mass very well. Okay, so let's take this question. We're going to calculate for the molecular mass and our molar mass. So let's say molar mass. Molar mass of the following compound. The first compound is, so let's take this example. Let's calculate for the molar mass for this compound. Na2CO3 NaCl. Also, let's calculate for CaCO3. CaCO3. So these are compounds that we want to calculate for the molar mass. In every question, they will give you the relative atomic mass of the individual element. So as I said earlier, sodium on the periodic table has relative atomic mass of 23. So that's equivalent to 8 mass. Also, we have Cl, which is equal to 35.5. We also have C, carbon. The mass of carbon is 12. The mass of Ca, which is calcium, is 40. So that's the mass of calcium. And also the mass of oxygen is 16. Okay. So we're going to use these relative atomic mass or masses to calculate for the molar mass. So let's take the first one as example. We have Na2CO3. So we have to break them down to the individual atoms in the compound. So for Na2CO3, we have Na, which is 2. We have C, which is 1, and O, which is 3. So to calculate for the relative molecular mass, you have to find the relative atomic masses of the individual atoms. So these are the relative atomic mass of sodium. So sodium is 23, but we have two of sodiums. So if sodium is 2, multiply the 2 by the 23. Also, carbon is 12. We have only one carbon in the compound. So we multiply the 1 by 12. Oxygen, we have 3 of oxygens. So we multiply the 3 by the relative atomic mass of oxygen, which is 16. So 16. Okay, so 2 times 23. So the relative molecular mass or the molar mass. So the molar mass of this compound would be 2 times 23 plus 1 times 12 plus 3 times 16. So let's calculate for the answers. So the first one, 2 times 23 will give you 46 plus 1 times 12 will give you 12. Then 3 times 16 will give you 48. So let's see. So for the molar mass of Na2CO3 will give you 48, no 46 rather. So 46 plus 12 plus 48, which will give you 106. But molar mass has a unit, the SI unit for molar mass, SI unit for molar mass is grams per mole. So you just write grams per mole. So the molar mass of this one is 106 grams per mole. Okay, so let's calculate for that of sodium chloride. So as we did for the first one, let's break it down. We have sodium, only one in the compound. We have chlorine, so we are doing this sodium chloride. We have chlorine, which is only one. You get it? Okay. So we know that Sodium is equal to 23. Chlorine is equal to 35.5. So they will give the relative atomic masses of the element for you. So we have 23. So sodium is 23. The one in it, in the sodium chloride, we have only one. That's why we've written this one. So 1 times 23. For the chlorine, we have 35.5 and we have only one chlorine in sodium chloride. So 1 times 35.5. So this will give you 23. This will give you 35.5. Therefore, the molar mass of chlorine, no, sodium chloride, will give you 23 plus 35.5. Or you can write 1 times 23, 1 times 35.5. After that, you break it down to 23 plus 35.5. It will give you 58.5. And it has unit gram per mole. Gram per mole. I hope it's clear. All right. So let's solve calcium carbonate. You can try your hands on it. So you can pause the video and try your hands on calcium carbonate. All right. So let's try for calcium carbonate. Okay. Calcium carbonate. We know that calcium relative atomic mass for calcium is 40. C equal 12. O equals 16. So that's the relative atomic mass. So for calcium carbonate, we have Ca, only one in calcium carbonate. We have C, only one. And we have O, which is 3. Okay. Then you multiply these numbers by their relative atomic mass. Calcium times 40, because the relative atomic mass of calcium is 40. Carbon, 12. Oxygen is 3 times 16. Okay, so relative or molar mass of calcium carbonate is equal to 1 times 40 plus 1 times 12 plus 3 times 16. So 1 times 40 is 40 plus 1 times 12 is 12 plus 3 times 16. 3 times 16, which is 48. So the total will be 12 plus 40 plus 48, which will give you 100. And it has a unit, grams per mole. Okay, let's try our hands on different examples. Okay, so let's try our hands on sodium hydroxide, HCl, then NH3. So I said earlier they will give you their relative atomic masses or masses. So Na equal to 23, H equal 1, Cl equal 35.5 N. So for N, nitrogen equal to 14. 14. Okay, so let's solve for them. So we have for the NaOH, we have NaO and H. So Na is 1, O is 1, and H is 1. So if you then next step we multiply them by their relative atomic mass. So Na is times 23. O O equals 16. So O is times 16. H H is times 1 because it's 1. So H is times 1. So the total here will be 23. Here will be 16 and 1. So the relative or molecular or molar mass of NaOH is equal to 1 plus 23 plus 16. So 1 plus 22 will give you 24. 24 plus 16 plus 16 will give you 40 grams per mole. So 40 grams per mole. I hope it's clear. All right. So you can try your hands on ACl and NH3. Okay. So let's solve for ACl. And solving for ACl. So let's solve for HCl. H and Cl. So how many H do we have in HCl? We have 1. How many chlorines? We have 1. Then we multiply it by their relative atomic mass. For chlorine is 35.5. For hydrogen is 1. So 1 times 1. So HCl molar mass for HCl will be equal to 1 plus 35.5 because here will give you 35.5 and here will give you 1. So 1 plus 35.5 will give you 36.5 grams per mole. Okay, compound is NH3. So yes, we said N equal 14. The mass of N equal 14. H equal 1. Okay. So how many nitrogens are found in NH3? We have only one nitrogen. And how many hydrogens? We have 3. Then you multiply it by its relative atomic mass. You also multiply it by its relative atomic mass. So the molar mass of NH3 will be equal to 14.3. So 14 plus 3, which will give you 17 grams per mole. So I think that's all for molar mass. Let's move on to the relationship between molar mass and amount of substance which moves. Okay, so for you to calculate for moles, I said earlier that you need molar mass. It forms is one aspect of one thing that you need when you want to calculate for moles. you also need mass. So things you need to calculate for your moles. So if you want to calculate for moles, is amount of substance N. If you want to calculate for N, you need mass. So this is amount of substance. So this is mass. Then you need molar mass, the one we just learned how to calculate. So the mass. Molar mass. Okay. So if you want to find the relationship between moles, mass, and molar mass, moles equal to mass over molar mass. So note this formula. If you want to calculate for moles or amount of substance and they give you mass, you can calculate for the molar mass of the compound. That is what we just learned earlier. Then you divide the mass by the molar mass. The answer that you will get will be the moles. Okay, so let's take an example which will lead you to understand whatever I'm trying to say. So okay, so we said this is the relationship between mass, moles, and molar mass. So if they give you mass and they give you the compound, you can use the relative atomic masses to find the molar mass. We just did. So you use it, you divide it, you get molar mass. So let's take a question. Okay, so let's see this question. The question is calculate the number of moles contained in 20 grams of aluminum atoms. Al equal 27. So I told you always they will give you the relative atomic mass of the atom or the molecule they want you to find its moles. So if you read the question well, you can see that they've given you mass. So our mass from this question is 20 grams. They've also given us the relative atomic mass of aluminum. So Al equal 27. So they are asking us to find. All right. So from this formula, we know that N equal to mass over molar mass. Okay. So let's take them one by one. Mass is 20, and molar mass here is equivalent to the relative atomic mass because for aluminum atom you only have one aluminum in aluminum atom. So if you take aluminum atom, it's just this aluminum atom, which is only one. So it will be one times the 27 given. The 27 given. Because aluminum atom contains only one aluminum. So it's one times 27. Okay, so it will give you 27. So you place the 27 here, then find your answer. So 20 divided by 27 will give you 0.7, 0.7, 0.741 moles. So that's N. So that's 0.741 moles. So that's the answer for this question. So let's try our hands on another question. Okay, so let's solve this question. So the question is calculate the number of moles contained in 48 grams of magnesium oxide. Magnesium oxide is MgO. Mg equal 24, O equals 16. So we know that this formula N equal is what we are looking for. Mass is 48 grams. Then we need molar mass. So let's calculate for molar mass. For MgO, we have only one Mg. So Mg is 1 times its relative molecular atomic mass, which is 24. Then we have O, which is only 1 times its relative atomic mass, which is 16. So molar mass of MgO will be equal to 24 plus 16. So 24 plus 16 will give you 40 grams per mole. So that's the molar mass. Okay, so we're going to substitute the molar mass into the equation. So N equal to mass is 48 all over 40. So N will be 48 over 40 divided by 40 will give you 1.2 moles. So this is the answer. You can pause and also go through the solution for you to understand well. Let's take another question. Okay, so let's take this question. The question is calculate the mass of 0.7 moles of calcium carbonate, which is CaCO3. CaCO3. So let's solve it. So from the question we have N, which is 0.7 moles. The question said we should find mass, so we need mass. Then they've given us calcium carbonate, so we need molar mass. So let's take calcium carbonate. So for Ca, we have Ca, we have C and O. For Ca, we have only one times its relative atomic mass, which is 40. For C, we have only one times its relative atomic mass, which is 12. For O, we have three. We have three O's here. So 3 times relative atomic mass, which is 16. So 1 times 40 is 40. 1 times 12 is 12. 3 times 16 is 48. So 40 plus 12 will give you 52. 52 plus 52 plus 48. 52 plus 48 will give you 100. So the molar mass of CaCO3 will give you 100 grams per mole. So we have 100 grams per mole here. Okay, so let's solve it. From this formula, we need M. So let's make M the subject. So from the formula, M will be equal to capital M, which is the molar mass, times the moles. So let's solve it. Capital M equal molar mass is 100 times 0.7. So mass will be 100 times 0.7. So let's see the answer. So 100 times 0.7, not 6.7, but rather 0.7. 100 times 0.7 times 0.7 will give you 70 grams is mass. So it's supposed to be 70 grams. So you can see where we started from. First, you have to write the parameters. N equals 0.7 moles. M is what we are looking for because the question said calculate the mass. Okay, so then you saw for molar mass from the compound given calcium carbonate. So for calcium carbonate, we have Ca, which is one, only one Ca in calcium carbonate. For C, we have only one, but for oxygen, we have three. That's why we've written this three. Then you multiply each compound by its relative atomic mass given. So Ca is 12, no, 40 rather. C is 12, is here, and O is 16. So you multiply, then you get their values. After that, you add all the values. You add all the values. So it will be 40, 40 plus 100 plus 48. 40 plus 12 plus 48 will give you 100. So 100 grams per mole. So that's the molar mass. After that, the question said we should find mass. So you make mass, this M. Capital M is molar mass and small m is mass. So you make the mass the subject, then it will be mass equal to molar mass times moles. Our moles were given 0.7 moles. You calculated for our molar mass. So it will be 100 times 0.7, which will give you 70 grams. So let's take our last question. Then we move on. We move on from the mole to different aspects of mole concept. So our last question. Okay. So let's calculate for this. So the question is calculate the number of moles present in 35.5 grams of chlorine gas, which is Cl2. So Cl2, Cl2, Cl2. So this is how it's supposed to be look like. So we know that N equal to mass over molar mass. We have mass, which is 35.5 grams. Here we need molar mass. Okay, so for molar mass of Cl2, Cl2 means two of Cls. So it means we have Cl, which is equal to 2. Then you multiply it by the relative atomic mass, which is 35.5. Okay, so the moles is 35.5 grams. And So this will be 2 times 35.5. 2 times 35.5 will give you 71 gram per mole. So that's the molar mass of chlorine, gram per mole. So we have molar mass, we have mass, so we can just substitute it here. 35.5 over 71. So N equal 35.5 divided by 71, which will give you 0.5 moles. So this is. So we're going to move to complex questions. Complex questions. So complex questions will give you the idea of what to look for. So let's take another question. Okay. So let's take this question. Is that consider the reaction represented by the following equation. So we have Na two CO3 aqueous plus MgCl2 aqueous going to form 2NaCl Cl, which is also aqueous, plus MgCl3 aqueous. So he said we should consider this reaction. Then calculate the mass of sodium triosocarbonate 4 needed to produce 8.36 grams of magnesium triosocarbonate 4. C equal 12, O equal 16, and Na equal 23, Mg equal 24. So what you have to consider is the reaction. Make sure the reaction is balanced. So from the reaction, if you get this type of question, make sure the reaction is balanced. So from the reaction, you can see that we have two NAs here, we have two Na, so it's balanced. C is 1 here, C, C is also balanced because we don't have any reaction there. So carbon O is 3 here, O is supposed to be 3 here, but at least it's balanced. So let's see. That how many, calculate the mass of sodium triosocarbonate 4. So sodium triosocarbonate 4, this is sodium triosocarbonate 4. Needed to produce 3.3 grams of magnesium trioxocarbonate. Magnesium trioxocarbonate. So the question was mistakes. So here we supposed to be CO3. Yes, CO3. Mg is 2, magnesium is 2, so CO3. So magnesium triosocarbonate 4. So O, here is O3. Good. So this is how it is. So how many of this will be needed to produce that? So he gave us, the question gave us 3.36 grams for magnesium triosocarbonate 6. Okay, so let's see something. If you get this reaction, you consider the moles. the moles carried by the compound in the reaction. So let's assume you have money. So you have money, but you want to contribute some of the amount to your class. So you have money, a day you send 50 cedis to school. So something came up and you want to donate 20 cedis to the class. So in the contribution to the class, yours is 20 cedis. But the money, actual money you brought to school is 50 cedis. Bringing this idea here, you will see that these compounds are having their actual moles. But based on this reaction, they use some of their moles in contribution for this reaction to occur. So for sodium triosocarbonate is only one because there is no value. Magnesium 2 is 1, sodium chloride is 2, and magnesium carbonate is 1. These moles that are found in front of the compound are termed as stoichiometric moles. So they are termed as stoichiometric moles. So that's the most, in case you in your class, that's the money you donate. So for them to form this reaction, they donate certain moles for the reaction to occur. So that is not the actual moles, but it's the moles that they donated for the reaction to occur. So they are termed as stoichiometric moles. So in this question, we will provide 3.36 grams of magnesium carbonate. And the question is asking that you calculate for the mass of sodium trioxo. So this sodium trioxo carbonate needed to produce the magnesium trioxo, 3.36 grams of magnesium trioxo carbonate. So first thing that you have to do is to compare their stoichiometric moles. So for magnesium carbonate, its mode donated is 1. For sodium carbonate, because that's the question, based on the question, that's the comparison. That's the only two species that we are going to compare is 1. So we call something mole ratio. So you compare their mole ratio. So the moles of magnesium carbonate over the moles of sodium carbonate is 1 to 1 because magnesium carbonate is 1, sodium carbonate is 1 based on the balanced chemical equation. So it's 1 is to 1. Therefore, it means the mass for this, the mass for the magnesium carbonate wouldn't be the same as the mass for this because we have to turn this mass into moles. Then we compare it with the sodium carbonate to get its mass. Okay, so let's calculate for the moles for magnesium carbonate. So moles for magnesium carbonate equal to mass over molar mass. So magnesium carbonate from the question, from the question, Mg is 24. So let's calculate for the molar mass. So from the question, Mg, So the molar mass, let's calculate for the molar mass. So mg equal to 20. So mg equal to 24. 24. But we have only one mg, so times 1. C equal to 12. We have only one c, so it's 12. Then then O equal to 16. But we have 3 of O's, so times 3. So it will be 24 plus 12 plus 48, which will give us, okay, so which will give us 84 grams per mole. So that's the molar mass for MgCO3. So we are turning the mass given for MgCO3 into moles. So we want to find it. So therefore, the mass is N equal to mass is 3.36 all over all over 84. So the moles of magnesium carbonate is 3.36 divided by 84, which will give you 0.04 moles. All right, so 0.04 moles. So it means the moles for this is 0.04 moles. So we've turned this mass into moles. Then we use the mole ratio to compare the moles. Since it's 1 over 1, it means the same moles will be equal to here. Therefore, the moles for Na2CO3 is also equal to 0.04 moles because it's 1 is to 1. So it's the same. So if it's 1 is to 1, 0.04 moles will be the same for the Na2CO3's moles. In case we are supposed to compare it with the NaCl2, then it means this moles is twice of this moles is for this because here is 2. So it means this will be for NaCl. Each moles as compared to this will be 2 times 0.04. So for this, each one is 2 times 0.04. But that's not what we need. We need this one. Okay. So we need Na2CO3. So once they are the same, 1 is to 1, it means they have the same moles. Okay. So once we have the moles for Na2CO3 to be 0.04 moles, then it means we can calculate for its mass because the question is calculate the mass of sodium triisobarbonate for needed to produce 3.36. So 3.36 is here. We turn it to moles to compare it to the Na2CO3. We've known that it's the same, so they will have the same moles. Then we have to turn these moles, the moles we've gotten for Na2CO3 into what we called mass. So let's turn it to mass. So it means first we have to calculate for the molar mass of Na2CO3. So Na2CO3 molar mass. So molar mass for Na2CO3, sorry, Na2CO3. So the molar mass will be, we have 2 of sodium. So sodium is Na is 23, so 2 times 23 Plus C, we have only one C, so 12 plus O. Oxygen, we have 3 of O, so 3 times 16. Okay, so, okay, so you know that the molar mass, so the molar mass of Na2CO3 equal to 106 gram per mole. So that's what we got when we solve it. Therefore, once we know that the moles of this is 0.04, and since the mole ratio of this and that is 1 is to 1, it means the moles for this side is sodium carbonate is also 1 is to 1. So therefore, N equal to mass over molar mass. So if you make mass the subject to be molar mass N, once we've got the molar mass, which is 106, times the moles, which is 0.04, the answer will give you 4.42 grams. So kindly go to, you understand, or I can still restart the whole question again for you to understand. So let's start the whole question again. You understand? Okay. So we have Na2CO3 plus MgCl2 going to form 2NaCl plus MgCO3. It's supposed to be MgCO3, not MgCO3. Okay, so this is the reaction. And the question gave us the mass for this, which is 3.3 grams. So it's asking for the mass of this. And what I said earlier is that you consider the numbers in front of the compounds. From here is 1. For this one is 1. Here is 2. And here is 1. For the one we don't write, that's why it wasn't there. They are termed as stoichiometric moles. That's the moles the individual compounds contributed for this reaction to occur. So we call something mole ratio. So we have to compare. We need the mass of this, but they've given us the mass of this. If you compare the moles or the mass of this and that, you see that they have the same moles. So we call them mole ratio. So the mole ratio for MgCO3 and NaCO3 is 1 is to 1. Therefore, it means either moles or mass of MgCO3 will be the same for the NaCO3. So the mass is 3.36 grams. It means the mass here will be 3.36 grams. If the mole is 0.04 moles, in case you turn this mass to moles, it will be the same for this one, 0.04 moles. You get it? Okay, so this is the mass for this. So it means you have to turn this mass into moles. So when we turn it to moles, we got 0.04 moles. So it means once is the mole ratio is 1 is to 1, it means we will get the same moles for here. Therefore, we can solve for the mass. So we know that N equal to 0.04 for this compound. Molar mass for this compound is 106 gram per mole. So molar mass is 106 gram per mole. Then it means that the mass will be molar mass times N will be 106 times 0.04. Mass will be 4.24 grams. So this is the mass for Na2CO3. The reason why the mass of this is not equal to the mass of this is because of the molar mass. So you have to turn this mass into moles, and you use the mole ratio I talked about to compare. So 1:1, it means the moles here will be the same moles here. Then you turn this mass, this moles into mass. So this is it. Okay, thank you. So in our next video, we'll talk about concentration. So our next video, we'll talk about concentration. So look for that video. Okay, thank you.